Hey everyone, today we are going to talk about using equivalent ratio tables to help us solve problems. So we've been working with simplifying fractions, using our multiplication chart, finding the greatest common factor. And now we're actually going to apply all of those things to use equivalent ratio tables. So we are going to talk about scaling forward and scaling backwards today. And you can see that my first definition here says, multiplying or dividing two related quantities by the same number is called scaling. So we are going to be talking about scaling forward or multiplying, and then scaling backward or dividing to help us solve these problems. So you can see in my examples, okay, I've got some scaling forward examples and I've got some scaling backward examples. You can see that I kind of take some of the information away as we go. So I've got everything filled in the very first one, and then I take some information away, and then I take some more information away, and then I'm going to have you guys fill in the entire table. So example 1 says, a recipe for 1 apple pie calls for 6 cups of sliced apples. And the first thing that I'm going to notice is in my question, it says 1 apple pie, and my table says number of pies. I have 6 cups of sliced apples, so the other part of my table says cups of sliced apples. I went in the order in the question, so the apple pies came first, so the number of pies comes first. I have cups of sliced apples second, so the cups of sliced apples is on the bottom. The order of these things does not matter as long as you have the correct value associated with each unit. So if I wanted to put cups of sliced apples on top, I could as long as I keep the 6 with it. So you can see in the table that there's 1 apple pie on top and there are 6 cups of apples on the bottom. And then I'm going to use my question to help me fill in the next part. So how many cups of sliced apples are needed to make 4 apple pies? So I've got my yellow highlighter there. 4 apple pies means that goes in the number of pies section of the table. Now, in my table, you can see that I've got 1 and 6 in that first spot, and then I've put the 4 at the end. There is a reason that I have put the 4 at the end, but it's not going to make sense until we've done all the examples. So this is going to be a replacement, for our tape diagram. So in the tape diagram, we were drawing a picture, a visual representation of being able to solve for that missing value. Now I'm going to use a table and my multiplication chart to help me find that missing value. This is called scaling forward because I am going to figure out what I multiplied by to get from 1 to 4. Well, I multiplied by 4. And whatever I do to the top, I must also do to the bottom. So I'm going to multiply 6 by 4, and I'm going to get 24. Okay, that's my work to get my answer, and now I'm going to answer the actual question. How many cups of sliced apples are needed to make 4 apple pies? 24 cups of sliced apples. Example 2 says a recipe that yields 12 cups of soup. So here's my 12 cups of soup. And then I have number of cups of soup. Okay, those are the same. Calls for 19 ounces of beef broth. And I've got ounces of beef broth in my table. How many ounces of beef broth do you need to make 36 cups of soup? So I'm going to highlight that cups of soup in the same color as cups of soup from the very beginning. So I know to put the 36 in the top part of my table. It's super important that that extra number, that piece that we're using to help us solve, goes into the right area of our table. So now this one is scaling forward because the number that I'm starting with is smaller than the number that I am ending with. So I'm using multiplication. 12 times 3 is 36. So I'm going to do 19 times 3 is 57. And then I answer the question, how many ounces of beef broth do you need? You need 57 ounces. Okay, in example 3, to make yellow icing, you mix 6 drops of yellow food coloring. So you can see in the top of my table, I've got drops of yellow food coloring. But now the box is empty. Well, in this empty box, I'm going to put a 6. With 2 cups of white icing, well, my cups of white icing go on the bottom. So I'm going to fill that in with a 2. How many drops of food coloring should you mix with 8 cups of white icing? So I'm using my bottom value here to get the same shade of yellow. So this is actually going to be the 8 on the bottom instead of the top this time. And again, making sure I'm putting it in the correct part of my table. So now I'm working on the bottom. How do I get from 2 to 8? Well, I multiply by 4. So on top, I'm going to multiply by 4. And 6 times 4 is 24. And then I'm going to answer the question, how many drops of yellow food coloring? 24 drops of yellow food coloring. This was scaling forward because I was multiplying to get from the first set of numbers to the last set of numbers. Now we're going to talk about scaling backward. Scaling backward means that we're going to end up dividing to get our answer. So this one says, at a dog shelter, a 24-pound bag of dog food. So I'm going to say here in my table, pounds of dog food. And I've got 24. We'll feed 36 dogs. So I'm going to have dogs, and there are 36. So pounds of dog food and dogs. How many dogs would you expect to feed with an 8-pound bag of dog food? So that's going to go in the yellow highlighted portion of my table at the top here. And I'm actually going to put this 8-pound bag in the middle. And the reason why I'm going to put the 8-pound bag in the middle is because from 24 to 8, the number is going down. So in my last example, from 2 to 8, the value went up. From 12 to 36, the value went up. Here, from 24 to 8, the value is going down. So I know I'm going to divide. So I'm going to put that value in the middle. To get from 24 to 8 by division, I'm going to divide by 3. And whatever I do to the top, I still have to do to the bottom. 36 divided by 3 is 12. And I'm going to answer the question. How many dogs would I expect to feed? I would expect to feed 12 dogs. Example 5 says to make cranberry jam, you need 12 cups of sugar for every 16 cups of cranberries. So there's the 2 things that are going in my table. So I'm going to have cups of sugar and cups of cranberries. So this is the top part, the yellow, this is the purple. I need 12 cups of sugar. For every 16 cups of cranberries. And it says find the amount of sugar needed for 4 cups of cranberries. So I'm given the purple information this time. And again, I'm going to put that in the middle column because from 16 to 4, my value went down. So to get from 16 to 4, I'm going to divide by 4. And I'm going to do the exact same thing on the top. 12 divided by 4 is 3. And it's going to be 3 cups of sugar. In example 6, Justin bought 40 packs of baseball cards. So I'm going to have packs of baseball cards for a discounted price of $64. So I'm going to use price for my second part of my table. So I've got packs of baseball cards. And I've got price. And that price is going to be in dollars. So this is my yellow. This is my purple. So I've got 40 packs of baseball cards for $64. If he sells 10 packs of baseball cards, so that 10 is going to go with my top value, and I'm going to put it in the second column because from 40 to 10, the value goes down. To a friend at cost, how much should he charge? So to get from 40 to 10, I'm going to divide by 4. So 64 divided by 4 is 16. And I'm going to say $16. Okay. So this is scaling forward and backward. Okay, so we scaled forward by multiplying. We scaled backward by dividing. I used pink and purple, or sorry, not pink and purple. I used yellow and purple highlighter to show the 2 different parts of my table and to show you that how I knew where each number belonged. And then you can either recognize what the multiplication or division is, or we can use our multiplication chart.